vertical 1.5 height. So height height given 1.5 meter, width given 2.8 meter, double plane window. So double plane now consists of two layer of glass by 2 centimeter air gap. So one glass, this one another glass. So between these two glass there's a gap. Air gap is 2 centimeter. And now room temperature. This one, the room temperature is 26 degrees Celsius, while the inner glass surface temperature, this inner glass surface temperature is 18 degrees Celsius. Now disregarding the radiation heat loss transfer, determine the temperature of the outer glass layer and rate of heat loss through the window by the natural convection. So we need to calculate the outer glass layer temperature. So this on the outer layer and this on the inner glass. And here's the air gap. Now we need to calculate the heat loss through the natural convection inside to the outside and the outside glass temperature. So here so we'll solve this problem based on some assumption. First one, the steady operation conditions, then air in the ideal gas, the air pressure in the enclosed here is a 1 atmospheric pressure, and radiation heat transfer loss is negligible. Okay, now for the natural convection between inner surface of the window and the room air. The properties of air at flame temperature. So here room temperature given 26, inner surface temperature for glass is given 18. So flame temperature will be average of these two is 22 degrees Celsius. Now at 22 degrees Celsius, for the natural convection between inner surface and the window inner room and the window inner surface, we'll collect the properties from the table A15 at 22 degrees Celsius. The thermal conductivity, Prandtl number, viscosity, and the beta is the 1 over the flame temperature. So now here 22 degrees Celsius. So 22 degrees Celsius. So here we have for 20, we have for 25. So we can use this to temperature data, and from here we can calculate for 22. So we need only the thermal conductivity. So these two, we'll use these two values, viscosity and the Prandtl number. Say for, if I show you how to calculate the 22, say Prandtl number at 22 degrees Celsius will be equal to Prandtl number at 20 degrees Celsius plus Prandtl number difference at which one, the next one, 20 and 25. So at 25 degrees Celsius minus at 20 degrees Celsius, then the temperature difference ratio. So it will be 25 minus 20, then wait, no, 22 minus 20 and 25 minus 20. So 2 or 5, yeah. So here, so Prandtl number for 20 degrees, this one, so 0.7309 plus at 25 is 0.7296 minus 0.7309, then temperature difference ratio 2/5. So it will be 0.7304 for 22. Same way we can calculate for the viscosity, also for the thermal conductivities. So here at 22, the thermal conductivity, Prandtl number, viscosity, and the beta, so 1/film temperature. Now also from this parameter we can calculate the heat transfer between room to the inner glass. Now for the next steps, so also we'll for the natural convection between the two glasses sheet and separated by a air gap. It's in between, here's the air gap. Now natural convection between two glasses, including the air gap. The properties of air will calculate for film temperature. Say here we'll consider the at the beginning the outer surface temperature, outer glass temperature is 0. If 0, then film temperature will be inner surface temperature 18 plus 0/2, so 99 degrees Celsius. Because this T2 is unknown at this point, so we'll consider as a 0. Then we calculate the flame temperature. Now based on this flame temperature, we will collect the properties from the tables. At the end, if we see this 2 is a big number, not close to 0, then we'll do we repeat the all calculation. And if we see calculated T2 is close to 0, then we don't need to redo the all calculation. So now for 9 degree, we'll calculate the properties for air. So 9 is directly not given. This is a 10 given, so we can use the 10 and 5, these two information. Then same way we can calculate for the 9 degree. It will give us almost same as the 10. The same way we can calculate for the 9 degrees Celsius. Okay, now these are properties at 9 degree for air. Now we'll do the analysis. First analysis we'll do between the room with the inner glass. Now inner glass is a vertical plate problem. So it's a room. So now we'll do the analysis between room with the inner glass. So inner glass, it is the vertical plate. If a vertical plate, so here length will be the same as height of the window is a 1.5 meter. As this one will consider as a inner glass is vertical plate problem. In vertical plate problem, then we'll calculate first the Ringling number. from this formula for the natural convection. Temperature inner, temperature outer, sorry, temperature room. How we did the so alpha, so room temperature, then inner surface temperature, then height to the power cube, and viscosity square, then Prandtl number. So here we will use the first set of properties, because this calculation for the room, between the room and the inner glass. So 9.81 flame temperature, if we convert to the Kelvin, how much was 22 if we convert to the Kelvin? So 222 plus 273. Then temperature was this one, 22 minus 18. Height is 1.5 cube. Prandtl number is 0.7304. Viscosity is 1.534 minus 5 square. It will give us 2.787 10 to the power 9. So this problem is related to vertical plane. Now from table here, our vertical plate, our problem is related to vertical plate, and there is a formula given related to Nusselt number, and here our value is 2.7 10 to the power 9. Now here this one range between 2.7 10 to the power 9. So the second one, this one equation for 10 to the power 4 to 10 to the power 9, second one 10 to the power 10 to 10 to the power 13. The last equation for interior range, for all range, but it is complex but more accurate. So we will use the, for this problem basically we can use this equation, or we can use this one, but it will give us the more accurate, so we'll use this value, so 9.21 equation. So based on the number we select for vertical plane Nusselt number formula from the table, and it is 0.825 plus 0.387, then numbers 1/6, then here 1 plus 0.492, Prandtl number, it's a complex formula, so 9/16, then again 8/27, then whole square. Okay, now here 0.825 plus 0.387, and this number we calculate 2.787 10 to the power 9. Power is 1/6, then 1 plus 0.492, Prandtl number is 0.7304, then 9/16, then whole 8/27, then whole square. It will give you 169.5. Now from this Nusselt number, we'll calculate the heat transfer coefficient. So heat transfer coefficient is thermal conductivity over height is Nusselt number 0.02529, 1.5, so 2.858 watt per meter square Kelvin. Also for rate of heat loss, we need to calculate the surface area. So surface area of the window, inner window, is height times width is 1.5 times 2.8, 4.2 meter square. Now heat transfer rate due to the natural convection is inner surface temperature T1. So here will be 2.858, 4.2, then 26 minus 18, 96 watt. Okay, now we'll calculate the temperature of the outer glass surface. And here the presented problem is a rectangular enclosed field with air. The characteristic length in this case is a distance between the two glass, the air gap, which will be the characteristic length, so equal to 0.02 meter. And this problem between two glass, it will be rectangular problems. In enclosed field here. Okay, now based on this characteristics length, we will calculate again the numbers, Reynolds number, and the same formula. Now temperature between inner glass and the outer glass, and the characteristic length cube, Prandtl number over the viscosity, and these properties at 9 degrees Celsius. We already calculate. We will collect these properties. We'll use the 9 degree. So here is a 9.81. So 1/9 plus 273. It will give us the beta. Then temperature difference, inner surface, inner glass temperature is 18 given, and outside we consider as 0. And here length is 0.02 cube. Prandtl number is 0.7339 at 9 degrees Celsius, and viscosity is 1.417 10 to the power negative 5 square. So we'll get this number as a 18,309. Now based on this number, from related to vertical rectangular cavities, we'll select the formula for the Nusselt number. So here our ratio height over length ratio, height was 1.5. Now here characteristics length is 0.02, the air gap, this height and this distance length is 0.02, so ratio will be 75. Now for these ratios, so you can see there is a one ratio this formula, if ratio is 1 to maximum 40, but our one is 75. There's another formula, this one range given 10 to 40. Okay, there's no correlation for this ratio, there's no formula related close to this ratio, but we will use the closest one. So closest one is this one, so 10 to 14, we'll use this one for the 75 because there's no available formula, so we'll use this closest ones. So if we use this one, so formula will be 0.42, then numbers 1/4, Prandtl number 0.012, then the ratio to the power minus 0.3. This one for the vertical enclosed formula. Now here if we use the all values, then Prandtl number at 9 degrees Celsius, then the ratio is 75, 0.3 negative, so it will give us 1.333. Now from here, under steady-state operation condition, the rate of heat transfer between room air and the inner surface of the window will be equal to the heat transfer through the air gap also. So we can use here Q H is surface temperature between inner surface and outer surface will be equal to this one. So here we will calculate this one is the 96, and H we didn't calculate yet, but we can calculate H from here, thermal conductivities, then length, critical length, then Nusselt number. So if we use this formula here, so K, Nusselt number, length, then area, then temperature difference. Okay, now we'll calculate the T2. Now if we rearrange the formula for T2, it will be T1 minus 96 times characteristic length over Canal thermal conductivity, Nusselt number, and area, surface area. So here is 18, but we'll convert to the Kelvin because from here we'll get the temperature, the Kelvin. So convert to the Kelvin, the T1, then minus 96, characteristic length is 0.02, thermal conductivity is 0.02431 times Nusselt number 1.333, and area we already calculated 4.2. So it will give us the 276.9 Kelvin. Now if we convert to the centigrade, so minus from here 273, it will give us 3.9 degrees centigrade the outer glass temperature, and at the beginning we consider T2 as a 0, then we calculate the flame temperature. Based on flame temperature, we select the properties of air, then we finish we calculate the Euler's number. Now here we can see is a 3.9 degrees Celsius, so which is very close to our assumed temperature. Therefore, no need to repeat the calculation. Say for this temperature, if we calculate the flame temperature, it will give you the new flame temperature is 18 plus 3.9 over 2. So 18 plus 3.9 divided 2 is 10.95. Previous flame temperature was 9 degree. Now if you go to the tables, so for 9 degree and 10 degree, our properties will be almost similar. That's why we don't need to recalculate again. We can accept this answer. So temperature of the outer surface is 3.9 degrees Celsius. This is our answer. Okay, then